In this video, we want to make our first confidence interval and talk about the steps that the AP exam will expect to see you write down in order to get full credit when you make one. This is from an old AP exam. A planning board in Elm County is interested in estimating the proportion of its residents that are in favor of offering incentives to high-tech industries to build plants in that county. A random sample of Elm County residents was selected. All of the selected residents were asked, are you in favor of offering incentives to high-tech industries to build plants in your county? A 95% confidence interval for the proportion of residents in favor of offering incentives was calculated to be 0.54 plus or minus 0.05. So if you want to actually calculate then what that interval looks like, it is 0.49 to 0.59. Okay, because of course this blue, what I'm going to circle in blue, this is our point estimate. And this is our margin of error. Okay, so point estimate, margin of error. Okay? Which of the following statements is correct? I often, with something like this, I think about, before I read any of the choices, what is a confidence interval telling me? The meaning of a confidence interval is, I am 95% confident that the interval from 0.49 to 0.59 captures the proportion of all residents, right? The whole point of confidence intervals is inference, that I took a sample and I'm trying to make a guess about the population. So I'm trying to say, based on my sample, I'm 95% confident that if I could ask everybody, that proportion of all would land in here. I'm going to start at the bottom with letter E for a reason. In repeated sampling, 95% of the time, the true proportion will be equal to 0.54. No, I'm confident that it will lie in there, in that interval, but not that it's going to be exactly the same. So no, E is out. In repeated sampling, this is D, in repeated sampling, the true proportion of county residents in favor of offering incentives to high-tech industries will fall in the interval 0.49 to 0.59. In repeated sampling, so this kind of sets up like confidence level. You know, if you remember, the meaning of confidence level is in repeated sampling. If all of the people doing the sampling created their own interval, then 95% of those intervals would contain the true proportion. This insinuates that if we did it over and over again, we would get the same interval. We would get this, and that's wrong. So D is out. Okay? And again, the minute they mention an interval, like in actual numbers, it's not confidence level. Because a level understands that while 100 people sampling might get all different intervals, 95 of those 100 will have an interval that gets the real proportion. Not that they have the same interval. Okay. In repeated sampling, 95% of sample proportions will fall in that. Okay, again, this is not about where sample proportions lie. This is about trying to find where the true proportion is. So this is out. Part B, at the 95% confidence level, the majority of area residents. That is incorrect. Our interval goes down below 0.5, so it's not a majority. The answer is A. At the 95% confidence level, the estimate of 0.54 is within 0.05 of the true proportion of county residents. That is the true statement in here. That is the closest to the actual meaning of the confidence interval. Okay, let's make a confidence interval. And I've filled in some blanks here just for time's sake, and I'll show you a couple of things as we go. We decided to take a simple random sample of Minnesota residents to see what proportion think more money should be budgeted every year for snow plowing. We take a sample of 860 people and find that 275 think more money should be budgeted for plowing. Find a 90% confidence interval for the proportion of Minnesotans that think more money should be budgeted. This is a four-step plan, or a four-step process to make a confidence interval on the AP exam. The first thing is state. What are we doing? What's our goal here? You can see I filled that in. We're building a 90% confidence interval for the proportion of all Minnesotans. Remember, this is all about inference. We've taken a sample. What do we think that says about the population? All Minnesota residents who favor a higher snow plowing budget. The next thing is plan. Okay, what are we going to do, and do we fulfill the conditions to be able to do it? The do is where we're actually going to build a confidence interval and conclude. I've already filled in, since we knew it was 90%. We're 90% confident that the interval from blank to blank captures the proportion of all Minnesotans who favor a higher snow plowing budget. Okay, so let's plan this. The first thing I'd like to calculate is my p-hat. Okay, my p-hat, my sample proportion is 275 over 860. That is approximately 0.32. Okay, so we are going to build a confidence interval for a proportion. Okay, so let's think about when we work with proportions, what things we need to do. We have kind of a zero condition, if you remember, and that is, do we have a simple random sample? It says that we do, so we're hoping we have good, well-collected data. Okay, that's the first thing. Now, the first real condition is our sample size of 860 less than or equal to 1/10 the population of all Minnesotans? The answer is yes. Okay. The next condition, I'm going to kind of go up here just for the sake of space, if you remember, is sample size multiplied by p, which for us is 275 over 860, or 0.32, which of course is 275. Is that bigger than 10? It is. Okay, and we also have to do that with the complement, 1 minus 275 over 860. This is equal to 585. That's also bigger than 10. We have fulfilled both conditions. Meaning, we can use the normal curve, okay, for this calculation. Now, I want to just explain real quick how this this calculation is going to work, and how we're going to get the margin of error. And I want to do it with kind of thinking about the normal curve, but then I want to show you a shortcut to this. Okay. To build a 90% confidence interval, what we really want to do is think about the normal curve, centered around 0.32 and a standard deviation that we'll calculate, and we want to catch the middle 90%. So we could use inverse norm to cut off 0.05 here and 0.05 here in those directions, and we could get those values. But honestly, those values are already calculated for us on a table in the AP exam, and I'm going to show you that in just a minute. So we don't necessarily need to use inverse norm to do it. We certainly could. But what that value is it's called Z star. Okay? It's the Z that we kind of fill in. So we have this formula for a confidence interval that really is all about the normal curve. It says, okay, we have a p-hat, that's the center, our point estimate. Plus or minus, we have a critical value that says, okay, how many deviations are we away that would cut off 0.05? And then that's multiplied by our standard deviation for our statistic. Okay, what I've just pasted in here is the bottom of what's called Table B, and it is included in the AP exam. It's also in your textbook. I also have a handout with it, but this is Table B. And at the very bottom of Table B, you see the confidence levels, and right above it, this is a little infinity, are the Z statistics that give you that amount of data, that percent confidence. So, we always think of 95% as being 2 deviations away. It's close. The exact number is 1.96. So for 90%, it's 1.645. So let's just start calculating here. We've got a p-hat of 0.32 plus or minus 1.645 multiplied by 0.32 times 1 minus 0.32 over 860, and of course we have to take the square root of that. Instead of parentheses, I'll use the square root. And we could calculate that, okay? And just remember, looking at the formula, you have your point estimate, and then this is how we get the margin of error. And again, it really just comes from the calculation with the normal curve, okay? The z tells us how many deviations we have to be away to cut off the percent we want, and this tells us the value of that deviation, okay? There's another way to do this, though, using the calculator. If you go to your stat menu, so press stat, and then scroll over to tests. And letter A on this menu of things is a 1 proportion z interval. And the first thing it asks for is an x. That is the number that said yes. N is the total number. And then the confidence level. So again, that progression is stat, and then scroll over to tests, and then you have to choose from a menu of options. This is letter A. So when you calculate, here's what you get. Here are the values of the lower and upper bound. So I can now fill in at this end that it's 0.29, I guess 4. I'll just go out to the 3 decimals, 346. That from 29.4% to 34.6% would capture this percentage or proportion of all Minnesotans who favor a higher snow plowing budget. Now in the next video I want to do another example, and I want to talk a little bit more about the formula, but make sure you have seen how you can get to this menu and find it, and make sure you kind of look over this 4-step process to building your confidence interval that they'll look for in the AP exam. And I want to come back just a little more to this formula.